Once EASyGrader is installed and you are ready to use it, the first step is to develop an assignment and also a rubric for that assignment. The problem statement that you distribute to your students has to include some pretty explicit instructions about how they must name their input and output variables so that their EES program submission is consistent with your rubric and can be automatically graded. So here I have made a very simple assignment that just asks students to calculate the surface area and the volume of a cylinder given its diameter and length. Notice that I am very explicit about how the input variables, which in this case are diameter and length, must be named. So in this case, diameter has to be named DCM and length has to be named LFT, as well as the units that they are in. So diameter is going to be in centimeters and length will be in feet. Similarly, I have specified exactly what output variables are required. In this case, it's volume and surface area. How they must be named, V liter and ASIN2, and what units they must be in. So volume will be in liters and surface area in inches squared. I've given the students a test case. So if they enter 50 centimeters and 12 feet for their input variables, they should get 718.2 liters and 9,514 inches squared for their output variables. It's probably good to reinforce this a few times for a large class, and one way is just to list the steps that should be followed when solving the problem right here in the problem statement. So step 1, enter the inputs in a dollar if not macro directive using the right name and units. Step 2, do whatever calculations you need to do. And step 3 is make sure that when you solve the problem, your solution includes the correct output variables with the correct names and in the correct units. In this case, you need to make sure that you have variables named V liter and ASIN2, and that these are your calculated volume and surface area in the units of liters and inches squared. It's probably a good idea to go one step further and actually post an EES starter file that students can download and use. This EES starter file can be automatically generated by EASyGrader, as we will see here in a second. And by distributing this starter code, you've really almost eliminated the possibility that students will mess up the naming convention. So the next step is developing your own EES solution to the homework problem. So this solution will become the basis of both the test case and the starter file, as well as the rubric that you use to grade the assignments. This is a pretty simple problem, so the solution is not very hard. Here I calculated the cross-sectional area of the cylinder, as well as the area of the sides of the cylinder, and then the volume is just the product of the cross-sectional area and the length, and the surface area consists of the sides as well as the two ends. So the variables V and AS are the answers, but they are neither named correctly nor in the right units. So the last step is to calculate V liter, which is the volume in liters, and ASIN2, which is the surface area in inches squared. So solving with the diameter and length set to 50 centimeters and 12 feet, respectively, results in the values that I used for the test case, which were 718.2 liters and 9,514 inches squared. I used these values in the problem statement so that students could check their solution, and I can also use these values to generate an EES starter code. To do this, select Create EASyGrader Rubric from the Outputs menu, and then select your inputs, which are DCM and LFT, as well as your outputs, which are V liter and ASIN2. Notice that the values in the units of these variables populate the boxes below. I want to use this test case to build a starter code that I can distribute with the assignment. So I'll select the Build Starter Code button here. And here's the result. You can see that in this edit box, the units are placed inside the dollar if not macro, so that when the EASyGrader macro opens the file, it can set and adjust these inputs according to my rubric. Note that I can either include units or not by checking this button. So I am going to assign points for unit checking, and therefore it's probably a good idea that I do include the units. And I can also either include the answers as a test case or not by checking this other button. Here I want to reinforce to students that these are the correct answers for the outputs that they should get if their program is working correctly, so I'm going to actually include that test case. And this is the EES code that I'm going to distribute with the assignment. So I can either save this as a text file, which EES can then open, or probably better yet, I'm just going to copy this and paste it directly into an EES file and save it, and allow students to download this EES file along with the problem statement. I can add more to the starter code if I want. So probably one thing I would do is actually convert these inputs to base SI units right here, just to reinforce to students that this is a good approach to take for problem solving. If I had some other units to the problem that weren't adjustable, I might add them here as well, just to save the students time and to save them the potential for making a mistake when they add them. If you do add other units that aren't adjustable, make sure you put them outside of the $if not macro clause. If I wanted to, I could even paste the problem statement into the diagram window just so the students have it readily available. Alright, to grade the problem, I want to use a completely different set of inputs. So I'm going to go back into my solution here, and I'm going to change the diameter and length to something else. And it almost doesn't matter what else, right? Something reasonable. So here are 30 centimeters and 9 feet, and I'm going to solve, and you can see now I get a new solution. Right? The values of my output variables have changed. And I'm going to use this new solution to generate my rubric that I use to actually grade the problem. By making the graded case different from the test case, we have ensured that the students do not just hardwire the solution into their EES code. By providing students with a test case, we are giving them the opportunity to identify issues before they turn in their homework, so they have time to go get help and see what's wrong. So to make a rubric from this new solution, I'll select Create EASyGrader Rubric from the Options menu. I'll select my inputs and my outputs again. So again, D centimeter and L feet, and the outputs are V liter and ASIN2, and you can see they auto-populate the inputs pane. I can have up to 3 inputs, and I can have up to 6 outputs. You can assign some number of points to each of the outputs, as well as some bands. So this is a percentage band around the correct answer, which will be accepted as the correct answer. If you want to add some completion points, you can do that down here as well. And finally, you can assign points for unit checking. If you do this, then EASyGrader, when it's grading each EES file, will actually check to see if there are any unit warnings detected. And if there are, then it will deduct this number of points from the score for that student. So finally, when I'm happy with the rubric, I will save it as an RBC file, and I will use this then subsequently after students submit their homeworks in the EASyGrader program to do the grading. The grading process will be covered in the subsequent video.